Bismillahir Rahmanir Rahim. In previous discussion, we have covered almost all topics from chapter 11 of your book, except one. So we may start that right now, but before that, as we had promised that we shall solve one or two questions in which data are given. So we may solve one or two questions from the previous discussion where we were saying that in case we are not familiar with the or we don't know what is the population's standard deviations. I mean when there are two populations. So when there are two populations and we don't know that what are the standard deviations for both, then we may take help of t statistic. And then there are two more cases. One case is that in which we assume that unknown population standard deviations are equal. And the second scenario was that the unknown population standard deviations are uh, unequal also. So they are unknown and unequal. So in both situations, we use two different formulae. One formula was if you see written in here in the summary of the chapter, we use this formula: t is equal to x1 bar minus x2 bar, where sp square is there. So we pooled the sample variances in this particular case, and this was this case where population's standard deviations were unknown but equal. We had assumed those as equal, so we use this formula, and in this particular case we use sp square. And here it was of importance that n1 plus n2 minus 2, this was the degree of freedom that we used. And then the other case was the unequal population's standard deviations. So in that case, we use this formula. And particularly in this case, we use this formula for degree of freedom. So in our previous discussion, we used this formula to find out the degree of freedom. And I have explained that the purpose of this formula is to reduce the degree of freedom. So in section A, I solved one or two questions where I used data. So better would be if you take that recording from section A's students. And one question or two questions that I solved in the previous lecture for section B, that was the case where data were not given, but in fact all required things were given. In that situation, we use this formula. So for section B, I'm going to use one question where I shall take data into my account and then I shall try solving that. So section A, did we solve this question?
No, sir.
Okay, okay. So we can solve this question. Uh, Commercial bank and trust company is studying the use of its automatic teller machines. Of particular interest is whether young adults under 25 years use the machines more than senior citizens. To investigate further, samples of customers under 25 years of age and customers over 60 years of age were selected. The number of ATM transactions last month was determined for each selected individual, and the results are shown below. At 0.01 significance level, can bank management conclude that younger customers use ATMs more? So you may solve this, you may start solving this question. Definitely, I am not going to write down each and everything right now because you are familiar with more things, many things. So simply, I'm going to write down one. So you write down null and alternate hypothesis. It is in this case, as we are talking about uh, average, mean, or average. So you will write down mu. So you can see over here, results are shown below. So basically, these are the transactions. So we are going to take into account the average transactions in younger customers case are more or not. So you will start solving this question. Null and alternate hypothesis, H naught, H1. So write down over here mu, 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 and there are two citizens, senior citizens and young adults. So you may give subscript as you may use this U and O. So you may write down U over here and O here. Similarly, U and O. So it's upon you. You may write down O here and U there. No problem. Okay. And then you have to read this statement. Can bank management conclude that younger customers use the ATMs more? Youngers are those who are under 25. So they are using more. It means you will write down, you will write this notation. You will put this notation over here. And the remaining two possibilities will come over here. Okay. So it is one tail, and then level of significance alpha given 0.01, 0.01, and then you can see over here, and the results are shown below. So you may, as there is no information regarding equal or unequal population standard deviations, we know that those are unknown, but we don't know that whether they are equal or unequal. So let's say they are unequal. Then test statistic will take this form. So if they are unequal, assumed unequal, the formula will take this form. Sorry, and instead of writing 1 and 2, you have to write down here U, O, U, O, U, and O. And then there is square root on this, there is negative sign, and here it is positive sign. So this formula you will use. This is U. Okay. Then there is fourth step, decision rule. And in decision rule, you will draw the distribution like this. And there are two scales. One is for x1 bar minus x2 bar. This scale is for this xu bar minus xo bar in this particular case. And this is the t scale. In the center, averages are equal. Here t is 0. And here mu1 is equal to mu2. In this particular case, mu u is equal to mu o. This is x u minus x bar o, this scale. Okay, so then you will see the kink. This is to the right side. So tail will be to the right side of the distribution. I mean, tail will be to this side. So 0.01. And for against this, you have to find out the critical value that will help you in determining that beyond which value you would reject the null hypothesis. So you can write over here T statistic table, come over here, and this is the table. But before that, you have to find out the degree of freedom. And for degree of freedom, as you would have to use the complex formula that is written over there in the summary. So better would be if you leave some space below this step and move to fifth step and then come again to this step once you find out the degree of freedom. So fifth step is computations. In computations, first of all, degree of freedom is required. So degree of freedom, the formula for that is degree of freedom is equal to, I'm going to write down the general formula first, S1 square. So in this particular case, it is SU. So you may take it as SU, but I'm going to write it down as S1. So that it remains easy for you to remember the formula. Plus S2 square over N2. Again, write down this S1 square over N1 plus S2 square over N2. Okay. Here you have to take the whole square, and here in this case you have to take square separately. And then you have to divide it with N minus 1 and N2 minus 1. So this is the formula that you will write down. Okay, so in this particular case, as we are using U and O as subscripts, so instead of writing 1 and 2, you may write down U and O. So you may change, or you may write down once again this formula, or as I have eraser with me, so I can simply rub this 1. So this would be SU. So you have to see over here that which was written first, which is greater. U is greater. So write down over here U, SU square, NU, SU, NU, sorry, SO and NO. This is SU, SU, O, O, and U and O. So now you may give the values, but you don't know what is SU square. You don't know what is SO square. So for that, you have to solve it manually. So on your answer sheet in the examination, if such question is there, you will solve it manually. How will you solve it? For that, I think I have written data over here. So I am taking help of Excel. You may solve it in Excel, or if examination is there in the campus, then you would have to use the manual technique. So these are the data values if you see. Yes, these are the data values. So A, or you may write it down as U, and you may take it as O. So these are the young adults, these are the over 60 years of age. So senior citizens. Okay. So here you will find out the degree of freedom. How will you find out? You are required, you have to use S1 square and S2 square. So formula for that you may recall. What will be the formula in case of SU square? SU square will equal summation. In this case, you are using U, so U minus U bar square divided by nu minus 1. This will be the formula. So variance, and SO square will be summation O minus O bar square divided by NO minus 1, like this. So we have series, and in series we, if we have U bar, then we may subtract, we may take square of that, and then we may take sum of that series. So then we will be able to find out SU square. So let us find. So first of all, we are interested in having the U bar. So how will you find out U bar? You may take it as this average of the series. Let's enter. This is the answer. For O, again write down average. Give these numbers. So we are basically adding these numbers and dividing with the total number of observations. So this is the average. And then we are interested in finding out U minus U bar. So you may write down U minus U bar. Come over here. Give this value. Write down equal sign. This value minus this value. And before pressing enter, put dollar sign over here. So the purpose of putting dollar sign is that we wanna fix this cell. We wanna subtract this particular value from all these values one by one. So now press enter. This is the answer, and now drag it down up to this point. Where up to this point, I mean where the last value is there, where there is last value. And then you are interested in having square of this, because sum for these values will equal 0. So we are not interested in this. We are interested in taking square of this. So U minus U bar and hat square. So now take square of all these values. So equal to this value and hat 2. This is the answer. And then again drag it down up to this point. So you have all these values, and now we are, as we are interested in having sum for this. So come over here, press equal, and write down sum, and enter. So this is the sum for this value for this series. And then you are interested in taking variance for this series. So what will you do? You may write down here equal to this value, okay, divided by uh, degree of freedom. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, or you may see from here 9. So subtracting 1, 8. Degree of freedom is 7. So 8 values are there. 1, 2, 3, 4, 5, 6, 7, 8. So nu is 8. Nu minus 1 will be 7. So you will write down over here 7. Press enter. This is the answer. So what is this? This is your SU square. This is your SU square. And then come over here again. Now take 0. Sorry, O. Let me write down in capital. O minus O bar. O minus O bar. So now here again equal this value minus this value, and you have to fix this cell. So put dollar sign over here like this. Press enter now. Come over here, drag it down up to this point. So all values are there. Again, we are not interested in having sum for this. So therefore, we will take square of O minus O bar square equal to this value, and you have to take square of this. So cap power 2, enter. Drag it down. This is the value. And now you have to take sum of this series. So press equal sum, sum and sum for these values. This is this. Okay, so what would be if we write down this sum over here? And then come over here, write down O square. So that will be equal to this value and divide by how many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 minus 1, 10. Press enter. This is the answer. So now you have found variances for first series, variance for second series. So variances are now available. And what you have to do now, you have to find out degree of freedom. And for degree of freedom, you have to use this formula. So you may take help of Excel again. Degree of freedom will equal, so as we are unable to, we are not interested in solving it directly, we shall solve it step by step. So equal to S1 square, so that is this, so this value is the square of this value, so square of this value divided with NU. So how many values are there? 8. So write down 8. And then you have to take care of braces. So see how I am putting braces over here. So this was the first value. Put brace over here and also put brace over here because we have to take square of two terms. Then write down plus, write down this value here, and you have to divide it with NO. So what was NO? Number of observations in second series. 11. 11 values are there. So divide it with 11. Close the braces twice. So this second brace is for this brace, the first brace. And now you may put square both terms. Press enter. This is the value. So this is now your numerator. This is your numerator. And now let us try finding the denominator in this case. So that will be equal to SU square, this value, divided by N1. That was 8. So 8. And see how I'm putting, how am I putting braces over here. This value, the value, and you have to take square of this. So take square, and then you have to divide it with the degree of freedom n1 minus 1. So that will be 7. So divide it, but before dividing put brace. Okay, so divided by, again put brace, n u minus 1, 8 minus 1, 7. Close the brace. Fine. And then if you see the formula, in the formula there is SU square divided by NU whole square. So this is what I have done over here. SU divided by SU square divided by NU whole square, and then divided with N minus 1. So I have divided it with N minus 1. And then I have to add this term in this, but before that I have to put some more braces. So close this, and if you are going to close this, then put another brace over here. And then come over here, press plus, and then you have to write down the other terms. So the other term is SO square. SO square divided by NO. So SO square is this. Okay. divided with NO. So what was NO? Number of observations in this series? 11. So 11, right? And you have to take the square of this. So take square in this way. And then close the braces. Close the braces from both sides in this way. Then come over here and you have to put slash for division and NO minus 1. So again, how many number of observations are there? 11. So 11 minus 1, 10. So you have to write down 10 over here. You have to write down 10 over here in the braces. And then you have to close the brace once again. Why? Because this brace will be there because you are putting this first brace over here. So for this first brace, this last brace will be there. So let us press enter. Okay. Let me check the braces. Okay, if it is not working and there is some issue, so what can best you do? You may take values separately. Don't write press over here, plus over here. D18 divided by 8 whole square divided by 7. So if you are doing it in this way, then there is no need of putting braces over here. Divided by 7. Don't put this brace. No, this will be there. Yes, this is the value. So this is the value for this term. And for this term, separately calculate. How will you calculate? Equal to SO square divided by NO. So NO is 11 divided with 11. And you have to take the square of this whole term. So put braces, base, take square. And then you have to divide it with NO minus 1. So NO is 11. 11 minus 1 is up to this point. You have to close the braces. Now press enter. This is the value. Okay. And for degree of freedom, what will you do? Equal to, this is your numerator divided by, this was the first value in the denominator, plus this was the second value in the denominator, and close the braces. Press enter. I think we have made some mistake. So I have to take NO whole square.
सर नोमिनेटर में मेरे ख्याल में मिस्टेक की है ऊपर वाले में डबल स्क्वायर लिया हुआ था ब्रैकेट के अंदर स्क्वायर नहीं लेना मेरे ख्याल में
Separate square we have to take, we have to write down this term plus this term and then whole square, and in this case separately square for both. So let us check it. Yes, 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 yes. This is the mistake. This is the mistake. You're right. Yes, you're right, boy. Enter. This is the value. If this is the value, so see automatically 15 is there. So it means that it is 15.9. So you will take degree of freedom as 15. You will take degree of freedom as 15. So this is what you have to write down over here. Degree of 15. Degree of freedom is equal to 15. Like this. Fine. So now you are able to find out the critical value. Now you are able to find out the critical value. How will you find out? You will come over here, T table, single tail, and point zero 0.01 was the given level of significance. So come over here, then come down until you are at 15. So the value is 2.602, 2.602. 2.602. This is the critical value. So here you will write down the statement that if I'm not going to write down that statement because I have written in previous questions, in previous solutions. So you may write down over here, if calculated value of t statistic will exceed 2.602, the critical value, we shall reject the null hypothesis because this is the rejection region. So this will be the fourth step, and basically you are interested in finding out the test statistic, that is t calculated, and using this formula you may find out this formula. So for this formula you again may take help of Excel because we are not there in campus, so we are doing things manually but using Excel. So let us see what happens. T is equal to uh, x1 bar minus x2 bar. So this was x1 bar, I mean xu bar, minus xo bar. Okay, and then you have to put the braces, but before that you may take numerator separately. Let's say this is the numerator. Let's say this is the numerator. So what will be the denominator? So for that, you may write it down as square root. Square root of what? Square root of S1 square over S2 square. S1 square divided by N1. So N1 was 8. Plus, so again here take care of braces, plus S2 square. S2 square means this value. This divided by 11. Close the braces. So these are the braces for this, and for square root, because you have to take square root of these two terms, braces around these two terms like this. So then press enter. This is the value. Okay, so now come over here, press equal to, this was your numerator, and divide it with this value. See the answer. The answer is 4.342. The answer is 4.342. So what is this? This is your calculated value, 4.342. Like this. Fine. So this value is larger than this value. So what will you do? You will reject H naught. So you write down over here as the calculated value has exceeded the critical value or the tabulated value of t. So we would reject H naught, reject H naught, reject H naught. So rejection of H naught, what this means, that meaning you have to explain in 6-step interpretation. So in 6-step, you will explain it. I'm not going to explain it. You will explain it in your own words, and you will write down in this way. Uh, as you are going to reject the null hypothesis, it means you are going to accept the alternate hypothesis. So exception of alternate hypothesis will mean that on average, the bank management, the bank management, yes, bank management can conclude that on average, younger customers use ATMs more. So you will write down this statement. Yes, bank management may conclude that younger customers use the ATMs more because we are accepting this. Fine. So then there are two more things. One is probability value. In this particular case, as it is one tail, so you may find out the probability value by taking help of this value 4.34. How will you find the degree of freedom? You have found as 15. So come over here, 15, and 4.34 you have to see here. So it is more than this value, 4.34. So against this value, what is the level of significance? It is 0.0005. So this value is the probability value, which is less than the given level of significance 0.01. So if probability value is less than alpha, we reject H naught. So that's what we are doing in this case. And now let us see another technique that is not required, but you should know that we are able to solve the same question if we give Excel, and this is very important, uh, not from the point of view of examination, but for your learning. How Excel may help us in finding all these values quickly in few commands. So see over here, data analysis. In data analysis, you may see T stat is T test, T test, T test. So what we have done? We have done this. Two samples assuming unequal variances. We have done this. So press OK. This window will be there. And see, you have to give the first series like this. Again, press this arrow. Come over here. Second series. Fine. Yes, labels are there in the first row. Alpha is 0.01. We know this is given. Output range you have to give over here. Let us give the output range at this point. Come over here, press OK. See, these are the values. So you may compare now that whatever you have done, that is correct or incorrect. So it has taken degree of freedom as 16. We have taken it as 15. Okay, no problem. We are interested in reducing the degree of freedom because we want to increase the chances of rejection of null hypothesis. And then you may see T statistic is 4.342. 4.342 we have found it manually. So same answer is there. Then one tail. So probability for one tail is, I have said that it is approximately 0.0005. So as we know that 0.4342, this is the exact T statistic. So for exact value, if you see this, for exact, as exact value is not there, exact value is larger than this. And if you see these values, these are reducing from left to right. Okay, so this value is smaller, and then whatever value will be next to this value, that will be further smaller. So what is that value? Excel is giving you the exact value, and that is 0.0025. This is the exact value that will be there for this particular value. So you may take it as 0.005 if you are doing things manually. So even then you may see that it is so small, probability value is so small as compared to 0.01, the given level of significance. So you would reject H naught. Okay. So if it was two-tailed, then you have to consider these values. So T critical in this case is 2.58. 2.58. So we have taken it as 2.602. So it is approximately, and Excel is taking this value exactly whatever value will be there. Right. So you may solve things in this way. Any question?
No, sir.
Okay, so let us solve the same question. If we consider, if we assume that the
No question,
uh,
sir.
unknown population standard deviations are equal. So let's say we are assuming this is one scenario in which unknown population standard deviations were unequal. So let's say they are equal. So if they are equal, then manually you will have to find out SP square. And if you are interested in taking help of Excel, so you may take help how data analysis. And instead of clicking this, click this to sample assuming equal variances. Okay. So now again give the range like this. Second variable. This is the second variable. Level of significance is 0, 1. Labels are there. You have to give the range, output range. Let us say I'm going to give it this range. Okay. So now you may see if it was one tail, this is the probability value. If it was two tailed, this was the probability value. If it was the case was for two tail, this was the case critical value. But in this particular case, as we know, it is single tailed, so you will take into your account this value, T critical for one tail 2.56. And you have to see this value, probability value, it is far less than the level of significance. So again, in this particular case, you are going to reject the null hypothesis. And you can see that in this particular case, the degree of freedom is 17, and we have taken it as 15, and Excel has taken it as 16. So in fact, as we are using that complex formula for degree of freedom, so we would have lesser degree of freedom. And if we are taking it as simply n1 plus n2 minus 2, then there will be a larger value for degree of freedom. Right? So how 17 is there? 11 plus 8 minus 2. The answer is 17. Right? So now you may solve all those questions that are regarding T and Z statistics when there are two populations in consideration. And as we have few more minutes, so we may solve another question from this, or we may take next section, next topic into our account. So what is your opinion?
As you wish, sir.
इसमें से
Okay.
था क्या एक और
So
Further
my opinion is
discussion.
that as we have done few things and we have to cover so many things, so better would be if we uh, take into our account next topic. So these questions you may solve on your own. You may try. Okay. The method is same. I've written these questions for you, but you have to solve these questions on your own now. Okay. So let us see this question. An investigation of the effect. This is the question from next topic. So try understanding this question. We shall solve it using another method. An investigation of the effectiveness of an antibacterial soap in reducing operating room contamination resulted in the accompanying table. The new soap was tested in a sample of 8 operating rooms in the greater Seattle area during the last year. The following table reports the contamination levels before and after the use of soap for each operating room. As the zero point zero 0.05 significance level, at the zero point zero 0.05 significance level, can we conclude that the contamination measurements are lower after use of the new soap? So basically, if you see this situation, you are using soap, okay, and you are checking the contamination level. So definitely, if you consider new soap as better soap, okay, and you are checking it for the same sample, for same you can say operating room where some germs are there, and you're using two different soaps for the same germs, let's say, so whether they are killed or not. Or you may consider another question and another scenario that is there in your book, in which he's taking quotations from the constructors for same size houses. Okay, so if let's say there are two companies or two constructors who are giving and in your book he's using appraise means they are giving idea or the prices or the cost values that they will obtain or get from the person who is interested in building some house. So let's say any one of you is interested in constructing his house of some particular area. So let's say there are two constructors in the market. So he may take the estimates from the both for different size homes. Okay, and then he finally decide that which constructor is better to hire. Okay, based on the sample values. So I mean the houses are same, the size of the houses are same, and two different constructors are giving you the estimates for the construction. So what we call this dependent samples. So if you see, this is the last topic in your book. We have taken into account independent samples up till now. We have taken into account independent samples up till now. But if you consider dependent samples, if you take into your account dependent samples, then you will be there in this section. Two sample tests of hypothesis, dependent samples case. So dependent samples means there is one sample. Let's say in this case, homes are there. So these are the homes A, B, C, D up to J, different sizes of the homes. And these two are the constructors, Shaddick and Boyer. So they are giving the estimates for the construction of the homes. So $235,000 if the home is of this size. If home is of some other size, let's say that is let's say 500 square yard and then 1,000 square yard and 800 square yard, like this. So B is some other home with some other size. For this, Shaddick has this estimate, has provided this estimate, and Boyer this estimate, like this. So different values for different homes. So homes are of different sizes, and let's say this was 500 square yard. So for this, Shaddick is providing you $235,000 construction cost, and $228,000 are being provided by Boyer to construct the same size house. Right. So in this way, definitely both constructors will provide you the different construction costs, right? And then you have to decide that which is better to hire. So let's say in this case, he is saying that can we conclude there is a difference between the firm's mean appraised home values, appraised mean estimated cost. So difference, the word difference is there, so you will use equal and unequal sign respectively in null and alternate hypothesis. Okay, but if there is more or less the word like those, then you will use the single tail test. So you may consider this question. You may solve it on your notebook. Okay, and in this case, we shall use this formula. This formula. D bar divided by SD and divided by square root n. So here D bar is basically the difference. I shall explain it. And what is SD square and what is n? So you will use basically this formula to find out the calculated T statistic. So let us solve this question. Let us solve this question. And for this question, I have written the values over here in Excel. These are the values. So see what is the question. Can we conclude that the contamination measurements are lower after use of new soap? So definitely you may consider this scenario as there were two soaps and there was some, let's say, some room, there was some germs and we checked the quality of the soap, that whether it is good for killing the germs. So how many germs killed before the introduction of the new soap? So two soaps are there basically, an old soap and a new soap. So definitely the formula for the new soap will be different, but we are applying these two soaps on the same germs. This is the scenario. So we want to see that whether the new soap is good or not. So in this particular case, if you see, can we conclude that contamination measurements are lower after the use of new soap? It means that new soap kills more germs because the contamination measurements are lower after the use of new soap. So you may set the null and alternate hypothesis in this case as step 1, null and alternate hypothesis H naught and H1. So in this case, instead of writing down uh, mu 1 and mu 2, we shall take into account mu d and mu d. Fine. So in this case, can we conclude the contamination measurements are lower after use of new soap? So in this case, basically we are taking D as new soap minus old soap, or you may take it as before and after. So after minus before, you may take it as after minus before. It will mean that new soap minus old soap, or after minus before. Okay. So definitely if contamination level is lesser after use of new, so it kills more. So A minus B will be some positive value. Okay, so you may write it down as greater than 0, and this will be less than or equal to 0. So if you are going to reject H naught, this will mean that the new soap is good. It kills more germs. So try to understand this in that way. So now there is no need of writing these two, but this is only for your understanding. Then comes to the next step, and that is alpha. What is alpha? Alpha in this case, 0.05. And similarly, if it was equal sign over here, then it would be two-tailed test. But in this particular case, it is single-tailed. Come over here, write down step 3. And as we are taking into account dependent sample, what is dependent sample? Homes are dependent sample in this case, that is there in your book. Explain. Homes are the dependent samples, and in this case, the contaminated water you may consider, that is the same sample against which you are applying the two different soaps, right? So dependent sample is there, and you are taking into your account two soaps in this particular case. So in a dependent sample case, you use which formula? This formula. D bar divided by SD divided by square root n. So write down over here D bar divided by SD divided by square root n. Right. So what is D bar? D bar is basically D bar. D is basically you have to write down the D. So I have written it as after minus before. Okay. And what will be D bar? D bar will definitely be the value that you will obtain using this summation A minus B, whatever value you will have. So different values will be there. And when you will divide it with total number of observations, so you have to count the total number of observations in this particular case. 1, 2, 3, 4, 5, 6, 7, 8 values are there. So divide it with 8. So in this way, you will have D bar. So let us have D bar using Excel. Here you can, you are interested in before minus, after minus before, after minus before. So you may write it down as A minus B, after minus before, equal to, so what will be this value? This value will be, sorry, I have to take this value after minus before. This is the answer. So this is basically your D. This is D, difference. So drag it down. You have generated this series that is for difference series like this. If you see this in your book, you may see difference. So this is the difference. And then difference minus the average of different series, and then square of this to find out this SD. So difference is there, and then D minus D bar. Are you with me?
Yes, sir.
Okay,
Yes,
equal
sir.
to this value. Okay, D minus D bar. So, but before that, acha, let's say this is the situation. Then you may you are not interested in writing down the formula. Then press this. So come over here. Equal to this value and take square of this. So divide by 1 from E and write it down like this. Then come over here. Equal to this value minus this value. But before pressing enter, put $sign because you want to fix the cell. Now press enter. This is the answer and come down. These are the values. So sum for these values will equal 0. We are not interested in that. Equal to D minus D bar, and we are interested in taking square of this. So come over here, equal to this value and take square of this value. You may double click this to have the values, or you may drag it down. So these are the values for D minus D bar whole square, and we are interested in taking sum of this. Why? Because SD square that is there in the formula SD is basically equal to summation D minus D bar whole square divided by a similar formula that we are using in case of standard deviation SD. Okay, and minus 1. So for this formula, we are interested in this numerator. So for that, we are doing this. So we have to take the sum for numerator, sum these values. This is the answer. This is your numerator. And then for SD, what you have to do, SD for SD, do square root of this value, and you have to divide it with n minus 1. So what is n in this case? 8. 8 minus 1 is 7. Close the braces. Press enter. This is the answer. This is your standard deviation. Fine. And now you are able to find out t statistic. How? It is t T is equal to D bar. So if you see this formula, what is D? What is there? D bar. What is D bar? This is D bar. This is D bar divided by standard deviation. This is standard deviation divided by degree of freedom. Sorry, no, not degree of freedom. Sample size n. What is n? 8. Close the braces. Minus 8.55. So this is your calculated value for T. Yes. Okay. So now come over here. Step 4. Take it as T scale. So if you are considering this as one tail, so the tail will be to the right side. And if you see the answer, this is a negative value minus, this is a negative value. So this will be to the left side. So you may consider the situation as basically the issue is that you have to see the average value, which value is larger. So out of these two, if you take it separately, which value is larger? So let us check. So this value before's value is larger. So what you have to do over here, you have to subtract after from before, after from before, not like this. What you have to do, you have to do it as D is before minus after. So in that case, this sign will be changed. This sign will be changed. It will be otherwise. In both cases, no problem. The answer will be same because rejection region will be to the right side. And if you take that value as positive, this value as positive, then it will be to the right side. But as it is negative, so it will be to the left side. So you may change the alternate hypothesis over here. So you may write it down as, understand? You may check the averages for both series first. No problem. So in both cases, let us see what will be the situation if it is left-tailed. So here T value will be 0. And what will be the critical value? You have to see degree of freedom n minus 1. So 8 minus 1, 7. 7. And what was the level of significance? 0.05. Single tail, 0.05. Come down. Degree of freedom is 7. So 1.895 is the critical value. And as you're writing it down to the left side, so you will put this negative sign yourself. As it is not there in the table, but we know that if it is to the left side, then this sign will be there. And then if you write down the calculated value that you have found here, it is minus 8.55. So 8.55 will definitely to the left side of this. So it is there in the rejection region. This hole is the rejection region. This is the critical point, critical value. So this value, the calculated value, is in the rejection region. So what you are going to do, you are going to say that uh, we are going to reject H naught. We are going to reject H naught because the calculated value is there in the rejection region. So that means you are going to accept this. You're going to accept this. An exception of this means B minus A. B minus A. If you consider in this way, so you may say that what the soap that you have used later on, the new soap, that is good. That is good to use because that will kill more germs, right? So this was the question that I have taken from your book, question number 41. So we may check the answer for this question. 41, chapter 11. This is the question. You can see 1.895 is the critical value. 2.91 we have just calculated. D bar is 3.11. We have calculated this. 3.11. So why is it is like this? Because we are subtracting B from A. So if you are subtracting A from B, then this will be positive. Right? Okay, so it is taking it as mu D greater than 0. And I have rubbed that. So the scenario will change accordingly as you are considering. If you are subtracting A from B, so then this will be the situation. If B from A, then otherwise. So it's upon you. You may take any strategy, but in both cases, what will be the result? The rejection will be there. Understand? So if you are going to use this strategy, then it will be this greater than. And if you are going to use this strategy, then it will be less than. So in both cases, the result will be same. And what is the result? That new soap is better to use because it kills more germs. Right? So answer match. Therefore, you may say that we have done it correctly. Fine. So you will use this strategy when there are dependent samples. Okay. Is there any question?
No, sir.
No, sir.
Okay. So thank you very much for your patience. Meet you next time, and let me write down your attendance first. So don't leave the classroom.
Okay, sir.
No questions.